This is the fourth mini lecture for section 6.1 of the textbook. Now let's talk about common denominators. Given a pair of fractions a over b and c over d, we often want to find an equivalent pair that share a common denominator. There's a lot of practical reasons why you might want to do that. Maybe these are two measurements that you want to get to match up somehow, so you can decide which is larger than which. It's a way of making the fractions kind of speak the same language. Okay, you can always do this by just multiplying the denominators and using the fundamental law of fractions. So, for example, given 7 over 10 and 5 over 6, we have, 7 over 10 is 7 times 6 over 10 times 6. So that's 42 over 60. And 5 over 6 is 10 times 5 over 10 times 6, which is 50 over 60. And, that way we get a common denominator. We can see, this one's a little bit smaller than this one. If we wanted, we could add or subtract them because they're speaking the same language. Okay, often though, and usually when we do things like this, we want the denominator to be as small as possible. And that's usually not going to be the case when you just multiply the denominators. Okay, so when we get a denominator that is as small as possible, that's called the least common denominator. If the fractions are already in simplest form, then that least common denominator is going to be the smallest number that is divisible by both b and d. In other words, it's the least common multiple of b and d. So this is how these ideas are related. The least common denominator is often the least common multiple of the denominators. So for example, 7 over 10 and 5 over 6. We'd want the least common multiple of 10 and 6. That's the smallest thing they both go into. So pause here and think about it. Make sure you know what that is. I'll wait. Okay, so hopefully you did pause there. If not, you're cheating, so pause now. Otherwise, I'll tell you that the answer here is 30. If you thought the answer was 1 or 2 or something like that, it means you're mixing the word multiple up with the word divisor. Remember how many times I lectured you about that in the first semester. Okay, we're looking for the smallest thing that 10 and 6 both go into, which is 30. Okay, so that's going to be our common denominator here. 7 over 10 is 7 times 3 over 10 times 3, which is 21 over 30. And 5 over 6 is 5 times 5 over 5 times 6, which is 25 over 30. So, we're seeing that those concepts of greatest common divisor, least common multiple are very, very important when you want to work with fractions. And when you teach, you'll probably find that there's usually, it depends on the grade, but usually there's going to be some kind of unit about those concepts, about prime numbers, GCDs, LCMs, and all that, before you begin talking about fractions, because it's really a necessary skill. And when you were in school, if you didn't get enough of that stuff, of greatest common divisors and all that, divisors, multiples, prime numbers, if you didn't get enough of all that, then it probably made it really hard for you to work with fractions. And if you have a hard time working with fractions, you should think about that. Maybe it's because you didn't really get enough of that earlier material. Okay, so let's wrap up this section by talking about rational numbers. Okay, we've been talking about fractions. Now let's talk about rational numbers. So the same point on the number line can represent many different fractions. For example, Yeah, let's say 5/4. So to illustrate 5/4, I would divide this, each interval up into 4 equal parts, and I count 1, 2, 3, 4, 5 away from 0. Okay, so that's 5/4. Okay, however, I can take the same number line I'm trying to make sure it lines up. And now instead of doing 5/4, let's do 10/8. So for eighths, I'm going to divide each unit interval into 8 equal parts. Okay, and then I count 10 from 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 over 8. Okay, these are different fractions, but they're equivalent, like we talked about in the last mini-lecture. Okay, but more than that, as points on the number line, they're actually one and the same point. So we have this idea that, you can think of a fraction as a set of instructions or, a part of a whole, and in which case, these are two completely different fractions. However, depending on how you illustrate the fractions, you might find that they end up giving you the same thing. So if I think of these fractions not as actions, but just as points on the number line, then I find that it's the same point. Okay, it's the same location. So the numbers that these represent are the same number. They are equal numbers. So this underlying point, the underlying number, is what we call a rational number. A rational number is a number that can be written as a fraction. So when I think of that fraction as a location on the number line, I'm thinking of it as what we call a rational number. So for example, as fractions, 2/3 and 4/6 are different but equivalent. As rational numbers, they are equal. In lower grades, let's say, maybe up to 3rd or 4th grade, the emphasis is on fractions and concrete representations. Like 4/6 would be, you have a pizza, you divide it into 6 slices, and you take 4 slices. So in the lower grades, that's the emphasis. In the middle grades, from around 4th or 5th grade and on up, middle school and high school, the emphasis is on rational numbers. Okay, and you start just viewing these things as numbers. Like 1/2, you all know that that's 0.5. But when you start referring to decimal representations, you're really thinking of fractions as numbers. And I think it's really important to understand that, because at this point in your mathematical career, for the past several of your math classes, you've been subjected to this idea that fractions are numbers on the number line. But that's not where your students are going to be if you're teaching in the lower elementary grades. And if you're teaching in the upper elementary grades, you're in the middle of kind of transitioning from one point of view to the other. And that's an important thing to understand. A lot of students, they've had algebra or pre-algebra or whatever for years, and then so when they get in an elementary classroom, they kind of retain that point of view, but that's not where the students are going to be at. And let me emphasize, for this homework and throughout chapter 6, do not use decimals. No decimals. Pretend you do not know what they are, because right now, technically we don't. That comes in Chapter 7. So as you work through these homework problems, as you think about everything in this problem, avoid using decimals. Don't use decimals. Do not get out a calculator and divide. Don't do anything like that. Okay, everything you do should be in terms of whole numbers or integers. Okay, no decimals for anything.